All right, for this lesson, we're going to take a look at multiplying a polynomial by a monomial. So, we can use algebra tiles to illustrate the process of multiplying a monomial and a polynomial, where all we're going to do is we're going to say that the side lengths we can see represented here are what we're multiplying, and as long as I match up the side lengths, it should effectively show what the results are going to be. So if I'm multiplying a short side length by a longer side length, this being a 1 and this being an x, then I'm going to get a shape that looks like this. If I'm multiplying a short side length and a short side length, then if I match up the side lengths, I get two shapes that look like this. When I combine these, well, now I have two x's, which are the long rectangles. I have two of the small squares, which are just 2. So it's going to equal 2x plus 2. In the second case, if I have a long side length, which is an x, and a long side length, which is an x, then they're going to multiply to make an x squared. And just like in the last case, if I have an x and a 1, they're going to multiply to make x's. For the last example, I can make the shapes based on what I'm multiplying, but then I also need to account for whether it's going to be positive or negative. Well, a white one multiplied by a shaded one is always going to make a white one as a result. A shaded one multiplied by a shaded one makes a shaded one as a result, but at the same rate, a white one and a white one are also going to make a shaded one as a result. So if I have a clear and a shaded, it should still be clear when I multiply them. If I have a shaded and a shaded, or a clear and clear, it's going to be shaded when I multiply them. Which means that this is going to give me negative 3x plus 3. For example D, I'm going to do the same thing. I'm going to say that these are going to give me big rectangles, big squares, and these are going to give me the rectangles. The shaded and shaded will wind up with the shaded, and the shaded times the clear are going to stay clear, and I'm going to wind up with 2x squareds minus 4x's. Same thing here. Shaded and a shaded is going to make shaded. Shaded and a clear is going to make clear, and I have 2x squareds minus 2x's. Now, if I'm going in the opposite direction, and I want to figure out what polynomials are being represented by the information I'm seeing, well, the first thing is, here I can see that this is going to have a long side, so I know that I need one that has a long side running through here. Same thing here. This is a long side. This is a long side. And this is going to be a short side. Well, if I assume that the top one is shaded, then in order to make this match, then this has to be shaded as well to make this as shaded. This has to be shaded to make this shaded. And the last one, the 1, has to be unshaded in order to make it match. If I do the other possibility that would give me the same product, then I'm going to assume in this case that the top one should be unshaded. In order for that to be the case, I need to leave these two as unshaded in order to have an unshaded times an unshaded, make the shaded in here. But then it also means that suddenly the 1 is going to have to be shaded. So if I reverse the signs on everything, if I reverse the signs on the x's and I reverse the signs on the constant, it will still give me the same result. What are the two polynomials that represent each of the diagrams? Well, the polynomials that represent the diagrams are, I have 2x squareds minus x. When I complete this, like I did up here, then here I have an x multiplied by 2x's minus 1. For example, C, when I reverse it, I have a negative x, and I'm multiplying that by negative 2x's and a positive 1. No matter which way I do it, if I have x times 2x minus 1, or if I have negative x times negative 2x plus 1, they'll both give me the same result. 2x squareds minus x, or 2x squareds minus x. Now, if I need to verify that this works, then I'm just going to sub in 3 for x to see if it balances out on both sides of the equation. Well, let's do it for the first one first. If I said that I had 3 times 2 times 3 minus 1 is equal to 2 times 3 squared minus 3. This is going to give me 3 times 6 minus 1 is equal to 2 times 3 squared is going to equal 9 minus 3. 3 times 5 is equal to 18 minus 3, and they both wind up equaling 15. If I try the other possibility we said, if I said that I had negative of 3 times negative 2 times 3 plus 1, does that in fact equal 2 times 3 squared minus 3? Well, we already know that this side is going to wind up equaling 15. We already proved that. So here I'm going to get negative of 3 is just negative 3. And negative 2 times 3 is going to give me negative 6 plus 1, which means that negative 3 times negative 5 would have to equal 15, and negative 3 and negative 5 do have a product of 15. And I can prove that either scenario is going to work.